Okay, hello. Welcome to the new episode of AI Office Hours. We have Atlas Computing here today. I'm excited to dive in about what you guys are doing, as well as discuss more in general about kind of AI safety in different aspects. I'll let you guys introduce yourself first, maybe Danielle and then Bogdan, and then we can dive in.
Sure. So I have a background in software engineering. For the 5 years before joining Atlas, I was working at a DARPA Air Force contractor on how do we rapidly adapt and integrate complex high assurance or otherwise safety critical systems. And the role I was playing was on tool development of the Stitches systems integration toolchain, which was actually one of the most successful DARPA programs of the past decade.
Hey everyone, thanks for having us, Illia and NEAR. I'm Bogdan. I'm playing a product role at Atlas. Started recently, so I concern myself with product development, product management, design, and a little bit of marketing.
Awesome. Yeah, marketing is the most important. As
We're stoked to have Bogdan with us.
I mean, that's the thing is like we can build whatever you want, but if nobody knows about this, it doesn't matter. So
that's right.
Exactly.
As a developer, reformed developer at this point, that's organization. But yeah, I guess we can maybe kick it off with kind of what are you guys thinking about from perspective of like what are the biggest risks? And let's just time bound it in like next 2 years versus not in longer term. But what are the biggest risks? Where do we see kind of potential failure modes? And is the current approaches people taking are sufficient slash like addressing those risks, right? And I'm talking about kind of general AI safety that Anthropic and a few others are doing. Let's kick off with that topic, and then we can spun off in other directions.
All right. So sure, it's never enough. Nothing is ever enough, right? That's the short answer. But to frame it, let's tell the audience who Atlas Computing is. So we're a nonprofit trying to run like a startup. It has a very high research profile. So we bring a lot of researchers and high performance industry people to all work on this like hard targeted AI problems. One of them is safe AI, and even more specific, guaranteed safe AI. The challenges, one of the biggest challenges is that nobody knows exactly what are the issues and what are the kind of issues we're going to encounter, next year and 2 years from now. The only good news here is that the field is making progress. All these fields, connected fields, are making progress. So hopefully we get better as we go. But there's no right answer in terms of how the world is going to look like 2 years from now. What's working in our favor is that a lot of smart people are paying attention to this, and they bring their domain knowledge to safe AI and other aspects of AI. Safe AI is not the only one, right? So that's what we're doing. We're trying to bring all these people together to work on these very targeted problems.
I'll add in a little bit. One of the things, for instance, one of the motivators for me coming into the work that Atlas is doing is if you look at our critical infrastructure, whether that's in our energy systems, in critical privacy, in military defense systems, the approaches to establishing really high confidence when you can't be wrong are really quite mature, and there are many different angles that are much more than just testing your system. But if you look at what we know how to do today, and what we've built out and deployed in AI safety, it's a lot more limited. It's a lot more narrowly to different test-based approaches, whether we call it red teaming or evals. At the end of the day, you're treating the system like a black box for potentially a really wide application domain. And if we extrapolate forward to places where some of these modern AI capabilities may be more and more in the loop of places with critical safety concerns, oh man, I hope we don't think that that's good enough.
But I mean, to kind of somewhat of a counterpoint, right? When we evaluate people for this critical decision-making, critical roles, right? We are also using tests and evals, and we're not even, like not trying to be that, adversarial, I would say, for the most of the times. I think the only difference is with people, we kind of usually do this test throughout probably like 20 years of their career before they get to a role which like the criticality of their decisions is growing over time, which obviously is not happening here.
I'd be curious, Illia, for you, when you think about whether to trust a human being on your team or someone who's providing services to you, maybe it's a human organization, and it has to be very reliable and robust. Getting, in some circumstance where getting it wrong would be catastrophic for you personally or your community. How do you approach trusting that human being?
I mean, usually you have like set of processes that like critical decisions are not in the hands of any single person, right? I mean, that's why we're building decentralized blockchains, which run, it's not a single server that's run by a single person. It's, a number of validators run by independent parties. They all have different acceptance criteria and processes, how they, pre-warm, pre-roll out. But even before that, let's say just like release process for a protocol, just to give a very like critical example, right? If something goes wrong, multi-billion-dollar protocol stops. And so you want to have like a whole back process, right? With canary runs, with, pull request reviews, with kind of lots and lots of different stages, as well as you want to know that people who are working on it are, at a certain bar of proficiency and skill and understanding of the system. And I think the understanding of the system is probably the hardest part from perspective of the kind of safety. But again, I think that my point is more that generally individuals are as susceptible to adversarial behavior as computers are, right? If it's not like a prompt injection, then it's a $5 range that physically trying to coerce you to do something. So I think to me, indeed, it's always, and this is the kind of, I've used this a few times. I think most of the safety issues are not the AI issues. They're the systems issues that we don't have for a post-AI world, right? If we assume AI is here and we have all those kind of AI systems, and again, they have some properties, right, which will be hard to observe. But again, humans are hard to like know what are the properties any individual person have. Like you never know when somebody will have like mental, for example, or burnout or whatever. And so you need to build systems around to modulate that and deal with that in general. So that's kind of why to me, and again, there's some things that are on the other side, kind of from attack side, AI is becoming just a tool for multiplying something that like individual would be already hard, right? So the good example I like is AI is really good at finding bugs, right? And like it's probably on an average side of any individual developer, but like developers are not really good. Like not really good at paying attention to read somebody else's code. And so here you can scale that specific instance of look at this function and find all the possible options how it can go wrong. And so if you have that at scale now running across every function of some code base, it's just gonna like statistically, given we know there's hundreds of bugs per 1,000 lines of code, it'll just find all the possible vulnerabilities, and now you can just go and attack that code. And like, yes, a human could have done all of that. It's just like you can do it at like massive scale now for reasonably cheap, right? It's going to cost you potentially like thousands of dollars for per like major vulnerability in some systematically important code. So I think that's to me is like a very much real-time security issue that we need to be addressing. And I know you guys are looking at form verification as a system around that actually ensures that the code, again, there's nothing about AI. This is a human problem as well. And so like, how do we ensure that the humans or AIs, doesn't matter, are actually producing correct code and the systems behave in exactly the same behavior we expect?
Right. So formal verification is not necessarily a method to around humans, is to verify more what humans do. I think guaranteed safety AI is bringing both humans and formal methods to this. Formal verification being one of the methods, and I think people in blockchain and crypto are more familiar with formal verification of lately, because it has been pushed with pretty good success in the last 5 years, I would say.
Yeah, I mean, definitely the risks in crypto are just usually higher per line of code, right? The smart contracts, like under 1,000 lines of code for the most part, or like a couple thousand. But if you mess up one line, you lose potentially hundreds of millions of dollars. And so that's where kind of the area for developing this is, I mean, people are willing to spend millions of dollars to develop better tooling for formal verification for that.
Right. Yeah, there is that nice opportunity in the blockchain space where, if you spend 2% budget against the size of your contract on safety, well, it's very easy to make the argument that's a reasonable investment. I'm much newer than Bogdan to working in formal verification, so I'll say a little bit of what I'm seeing, and then he can add in. I think a lot of people who are in the formal verification space and try to sell it think, oh, the reason to formally verify a system is to stop a bad thing from happening, to make sure, okay, we don't have some critical vulnerability that whether a malicious actor is involved or just a fat finger, we don't take down all the transportation systems that use Microsoft throughout the entire world. But it's very hard to sell people on, oh, do this difficult thing, and you'll rule out something that wasn't likely to happen anyway from your perspective, or we can't show you. We can show you bugs that we found, but interestingly, instead of selling the point about security, often people are more successful selling trust. So a place outside of crypto and blockchain where formal verification has really made headway in the industry is at Amazon's AWS. AWS has an incredible value in their brand of having their customers trust that they will, be stable, robust, private, secure, many things. And so selling trust to the customer instead of, security internally has helped AWS make a lot of progress, really getting value out of formal verification, but closing that full feedback loop up to senior staff. And then another exciting thing we're seeing is we now get some of the very highest performance systems by using formal verification. People used to think, oh, if I'm going to formally verify code, well, it's very hard to reason about code. I'm probably going to use a narrow subset of, say, C or whatever language I'm working in, and that's going to hit my performance. Instead, we now see that if you want to remove like final extra assembly instructions from a routine that's running billions of times an hour, which big companies like AWS absolutely would love to shave incremental instructions off. Sometimes the approaches are so unintuitive and hard to reason about as humans that if you hadn't formally verified that it really still does your SHA-56 hash correctly or whatever narrow functional contract you have, you would never get to that level of performance.
Yeah, there are a lot of examples like that, and where formal verification helps. Formal verification is not the only method. Formal specification, formal design also matter a lot. You need to know how to handle that. Yes, one of the risks and kind of barriers is the cost and the time and the expertise that it takes to perform formal verification. There's a question of where formal verification is necessary and where formal verification is necessary now. AI systems have a lot of components, and it's not very clear which ones need to be verified like right away. So establishing a order of priority for that and kind of attacking the problem as a kind of complete product problem is also important. To Daniel's example about AWS, there's another, I think, really good example of incremental help with the CompCert, the C compiler, CompCert. C is not, easy to formally verify as a language, but CompCert proved itself more reliable than GCC and Clang that have been around for a long time. And sure, the code extracted is not verified. The OCaml compiler is not verified. OCaml, runtime environment is not verified. But that doesn't mean you shouldn't verify anything, right? So even small incremental verifications along the way, or like of components in the system, still bring an advantage, at least of safety. So it's very hard to negotiate this. Formal verification is the silver bullet, and don't do it at all, right? Like people expect everything from formal verification, and if it doesn't give them everything, like, let's not do it. You have to do it, but at least on components and try it. And I think what AI brings now, and machine learning and large models bring to this equation, is a lot of help. Of course, that help can be taken like for granted and automatically. That needs to be verified. The whole solution needs to be verified. But I think it's, against the bigger problem, you bring bigger help in a way, right? So they balance each other, right? Like you bring a bigger gun to a gunfight.
Yeah, I think, you mentioned, right, the specifications, the defining the conditions of what you're trying to prove. That's a big part of the problem in the first place, because like whatever you prove, if you have unspecified kind of conditions, like for example, the memory doesn't get overrun. Like if you don't specify that, then your proof will be correct, even though like the code is still doing something unexpected from a general sense. And I think that's kind of generally the interesting challenge of even specifying all of the things that systems should do or should not do, right, is extremely hard. But at the same time, what LLMs are getting good at is kind of this common sense type reasoning, right? Where they're not maybe very good at like structured reasoning. This is why we have the, more kind of symbolic machines, right, for proving, etc. But LLMs can actually convert, like, hey, I want a program that like sorts an array to, sort an array and don't run out of bounds, right, and stuff like this. And so you actually convert into a set of conditions which like are common sense and you would not think of specifying, but LLM kind of knows based on statistical kind of data that those are the conditions. And I think kind of going throughout the steps, right, adding that semantic understanding and semantic kind of leverage is indeed starting to help to leverage these tools, which before, like indeed formalification, even for smaller smart contracts, right, it's like a three-man month job for like 100 lines of code or something. It's like a pretty ridiculous, complexity. And so getting to a level where, and it's because like actually writing specification first is taking like first human months, right, and then proving it. And so I think that those are fundamentally the pieces as we decompose it. But I mean, why I like this kind of, because you can map that to a lot of other processes, right? Because I mean, code is just like describing a process and kind of some transformation. And so if we're talking about medical, or if we're talking about, shipping stuff to space or whatever, like all of those places, they have kind of similar, like, hey, defining, sometimes it's really hard to define all of the criteria. Like for medical, the drug should not, have like weird side effects at, attacking part of your body that it wasn't targeting. But like defining that is, pretty complicated because you pretty much want to say it should not attack anything else, right? Define everything else in your body. So I think there's a lot of tooling that will need to exist that will just help with this definition process. And I know you guys have published, right, the toolchain for AI assisted code for specification, synthesis, and verification. So you're definitely working on this direction.
Yeah, to kind of plus one and lift out some of what you're saying for where can AI actually accelerate or otherwise improve the workflow of doing formal verification to create high assurance. Exactly as you're saying, well, LLMs today can pull from a vast pool of knowledge of kind of what humans have built up over time, can then leverage that back to have conversations and discussions around what should be required. What are considerations that you don't want to forget about? If people are doing code generation today, they just get the code and it either works or it doesn't, and maybe they're going to review all the details of it, but often not. It'd be really good to have a bit of an intervention of a conversation that says, okay, you're working with medical data or financial information. Okay, maybe you should consider authentication. Let's think about some rules you would want about privacy. So that's a way of leveraging context. We also know, okay, LLMs are good with language and translating between representations of the same information. And so just as we're seeing with like GitHub Copilot or these other code synthesis and code explanation summarizing tools, one of the challenges with formal verification is, okay, you're writing these specifications that need to be machine understandable, so they look like code. You want to move between the high-level human intent and again, those discussions of, well, what should this be, and push that into formal specifications that machines can have reason about effectively. That's another thing that I think there's lots and lots of promise for modern generative AI to be helping out. And finally, and Illia, you named this one as well, but there's a lot of grunt work when it comes to then doing formal verification or even other kinds of formal reasoning that might give a lower confidence bound. And a lot of the work is very repetitive, and yet only some specialists have that built up set of skills right now to write just the right loop invariant for don't overflow this integer boundary in in this sorting routine or whatever it is. And like those kinds of highly repetitive, fundamentally coding tasks, it's proof coding now, look a lot like what we're seeing LLMs be very successful with in software.
Yeah, I think there's an interesting point just for people who are not familiar, because a lot of those tools are coming from pretty much mathematics, where I use for mathematical proofs. And the interesting property that proofs have is composability, because if you have a proof of some property and then you use this property in your other in proving something else, right, it kind of naturally either works or doesn't. Like that proof itself is kind of plugged in into the kind of bigger proof you're making. And so I think that's a very kind of important piece that's needed here, as you know, AI is generating more and more code, and obviously this is one of the things I'm working on, that we want to use, you know, libraries, we want to reuse some other code. All of this will one way or another be generated by AI or built by people, but you have no guarantees around its kind of quality and safety. And so having this proofs is fundamentally allowing now to compose, and then if your precondition says like, hey, it cannot overrun memory, and you're using something that doesn't have those precondition, it actually will, and like the proof is not there, it will actually fail. And so you have this like really nice properties of composability that you don't have right now in the code, because, for example, tests don't usually compose in the same way, where you're like testing for kind of some other like edge case of some other module in a library in your tests. So I think that's a really like powerful property that at least like I wasn't immediately obvious to me until I learned that kind of how the mathematicians now work, where it moved away from, you know, sending each other PDFs with proofs, but actually just sending lean proof, and you can plug it in into yours. And so now you can work with anybody. Like you don't really care like who that proof came from, like who that lean file came from. Like you can plug it in into yours, and then if it all compiles, then you know things are working. So, and I think Rust is the only like programming language that's like close enough to that state where, you know, things compile, most probably they actually work. There's still maybe like logical bugs, but from a coding perspective, that was also an interesting experience.
Mm-hmm, mm-hmm. Yeah, I like what you said about tests not composing. One of the almost mantras from the previous organization I worked with was constraints compose, examples don't. If you have a list of requirements, you know, if you got the requirements correct and now someone else has their requirements, your requirements are still necessary. And these do compose really nicely, certainly at the informal language level. There can be challenges as we, you know, talking about formal verification. Well, now there can be syntactic challenges with aligning just the definitions. What are you semantically saying? But conceptually, at least, we're in a better starting point.
And to make things more complicated, you know, Guaranteed Safe AI is trying to bring users, people in the loop, allowing them to write the rules, write the specifications, and the specifications to be verified, take into consideration this user opinion. And Illia, I know you guys promoted this user-owned data and user-owned AI. You said previously that Alex is working on a product, Yasna, that we don't know much about yet, or I don't know much about. So maybe we can talk about this overlap of the human-centered approach of how the end user is included here.
Yeah, I mean, that's a good question. And this, I mean, part of it spans from that right now, you know, OpenAI, Anthropic, right? These organizations are very much like, hey, we need to make AI safe. And their definition of safe is safe for them. because they don't want to get sued by somebody. That's really the main like. And I mean, Anthropic is maybe a little bit more trying to figure out what does that mean, but like generally, like the safety for a company is safety for the company, and so there's no actual like. And yeah, I mean, they like, because of this, the filtering they're doing, they're like declining to give you legal advice, etc. It all spans from that, like their business that needs, that trying to make money and trying not to get into trouble for providing that service. And so I think that's why, like, I think it's important to understand that when people think of safety, kind of coming from companies. And so kind of the opposite side of this, similarly how it's opposite for companies trying to make money from you, user-owned AI is about how do you make money, or how do you benefit, not just in monetary, but also like in education, in opportunities, in ability to learn and explore the world, and kind of intrinsically motivated as well, right? And so that's where like we want to really focus on and kind of provide really an alternative to what kind of I call it for-profit AI, because it's less about open or closed source. It's more about the motivation and kind of incentives that they're driving it. And now similarly on safety side, it's the same idea. It's like now it's not about safety of the company that produces the model, but it's about like what is the safety for individual, right? For the safety for organization, for a company, for community. And I think there it's actually a lot less about that the model will output some garbage or some incorrect legal advice or whatever. It's more now about actions. It's like you don't want model to take actions which are not benefiting you, or potentially creating concerns. And this is again where some form of creating set of constraints that you want models to live in. And like, I mean, the example to use in Web3, right? Imagine you have a trading bot or whatever that you instructed to do things, and it potentially like creates and makes a mistake or whatever, gets hacked by prompt injection. Like, it doesn't matter, but it should be guaranteed to not be able to execute something that's like not beneficial, right? So for that you need like, what are those constraints? What are the ways to kind of define? And again, there you can actually escalate to a user and say like, hey, this is happening. These are like, it's outside of constraints. Like, for example, you're swapping something, or like it's trying to unwind your positions, etc., and it's not, it's like too much slippage or something, right? It's like, do you want to proceed with this? So you always have an ability to kind of go back. I think with knowledge retrieval and with anything like that, I think designing as well in such a way where you have multiple points of view, you have a way to see kind of the sources and like voices that said it. Again, this is more, I mean, it's not about like, again, safety in the same sense. It's more about understanding that there's something that are facts and there's something that are opinions, right? And really distinguishing those. And again, this is something that I think it's been, we in general, like with social media and search engines, are kind of starting to lose the grip on. And so I think it's important to, again, design products around that. And so, and again, this is like, this only will happen if you start designing around the user, right? Because if you're trying to design around a profit for a company, you don't care. You just like show whatever they spend most time on, what they click on, what they buy. And so you don't have the same motivation to like, okay, well, you want to build an informed public. You want people to be, more educated. Like a year later, we want people to be more educated than average and have a more informed opinions. Like nobody has such a goal, right? Even the government doesn't have such a goal. Uh, so like how do we actually set incentives to generate that, to drive that toward individuals? And I think this is where, I mean, blockchain to me is really powerful tool to do that, because it has so much individual incentives as well, right? We want more people to be kind of educated, participating, and being active members of this community, until we have the motivation to actually create value for them.
Right. So let's make it clear for the audience that safe AI is not the only approach out there, and there are more. There's human-centered AI and trustworthy AI and explainable AI and responsible AI that are coming from this angle of representing people and keeping people's interests at heart. And I think that makes it very complex on both technical and product side. On the technical side, yes, you can employ formal methods, formal verification, but if you're dealing with components that inform each other or change each other, and the system changes as you go, whatever tests or properties you wrote might not hold, or they might change as during that conversation between systems or parts of the system, right? So that's kind of the technical challenge. And on the product challenges, getting out of just the technical approach, right? Like starting with human goals and also verifying if those are accomplished. And it's not just about the company, and it's not about the profit maker.
Yeah, I'm curious how you guys see as on the product side for use cases where it's not engineers who are actually interacting. How will people both define their criteria as well as understand kind of if things are matching that?
It's hard. I think there's a lot of fear, first of all, about how AI reacts in general. So everything you read or like hear in the press, it's about this doomsday view that something's going to go wrong and it's going to go terribly wrong, and we're going to have a nuclear war in our hands because of AI. Maybe. We don't know. And I think the product approach here, when probably the safe product approach is start looking at how each component determines an outcome and still keep it manageable, and trying to verify components as they relate with other components in the larger system as much as possible. I mean, there is no, like you said, it's hard enough to do it for 1,000 lines of code. It's really, really hard to do it for 1,000,000 lines of code, right? So no one knows. But again, the good news is that these components are in the focus of very smart people. So, what is the best language to write specifications from the human point of view, right? In so many details that need to kind of be ironed out. And so Atlas is just a kind of a small part into that configuration of researchers, industry, policymakers, think tanks. I mean, it's the whole society, merging here. It's not just one company with one technical solution.
Yeah. I strongly echo the sense that there's not, one singular solution for every industry and application. Domain expertise matters a lot in reasoning about what do we want, what would be okay and not okay, and how could we achieve that. And so I don't think we've seen too much domain specific safety in especially the larger dialogue around, well, okay, how should we be moving forward? Maybe this is because a lot of people's idea of modern AI is ChatGPT, which you can kind of talk about anything. It's like super domain agnostic. But I'm looking forward to that shift towards domain specificity. I guess I'll add to that. one more thing actually would be there's where it hits consumers directly. A customer is using some service that's explicitly involving LLMs or artificial intelligence. Maybe it's a natural language interface, and so they know there's AI in this. Maybe they're authoring an agent to go off and do something, or authorizing an agent to do something. And then there will be lots and lots of products and capabilities using modern AI capabilities that are not immediately visible to the consumer. Oh, this is AI, but it will have many of the same big picture questions we're concerned around, when can I trust heuristic reasoning? What will and won't generalize? Am I in the safe domain area or not? What do I care about ethically and from a safety perspective? And this is where, of course, as a society, we have to start having conversations about governance, and we have to have ideas and approaches for how governance and policy and regulation and so on will integrate into these systems. This, I think, hopefully gets at a lot of the values you've been naming, Illia, of it's not one company deciding this is what's best for us and we'll pretend it's best for the world.
Oh, come on. Every company is changing the world to the way they want it, right? Yeah, I just wanted to mention, I think to me, a lot of the fear for AI, outside of it's coming from movies, right, is really coming from people projecting their own stuff onto AI, right? The nuclear war part is, literally, humans are the ones who get us on the brink of nuclear war, right? We're at the fourth time right now in the last 60 years to get there, or I guess 80 years. So the reality is it's mostly, and same as oh, it's gonna kill us all, which I'm there's no value function, there's no incentive, because it's so much energy to actually try to kill everyone. It's way easier to just wait, create a social media platform that doesn't removes people from wanting to reproduce and then wait for 80 years, right? Oh wait, this is already happening, right? Our birth rate is reducing dramatically already, and we're kind of getting ourselves extinct ourselves, without any additional AI systems, right? It's literally our own incentive structures that designing that that kind of led to that. So I think a lot of it is just our projections, and so I think it's really important to understand kind of, again, even when we have AGI, it's still going to be a tool. It's still going to be somebody initiated and run it and defined it what the goal it is. And yeah, it can mutate the goal, whatever, but those are still based on some inputs, right? It's not going to be out of nowhere. And so I think those are really important points. And then the other point, and yes, somebody can design an AI that is designed to kill everyone, right? That's important to note. That's a part of the problem where now we have tools that are can behave at scale and plan potentially long term. But it's the same thing as if somebody right now sits in their evil lair and plans, destruction of the world, right? We need mechanisms to understand, detect, and kind of prevent that, independently of it's AI or a person is planning that and kind of some evil genius, James Bond style planning, I think. So I think that's a really again, from a systematic approach, how do we design things? And again, the nuclear war is interesting because how do we design a world where everybody's in check, right? It wasn't an AI problem. It was a people problem that we need a set of motivations such that everybody knows they can destroy each other. And so okay, we're going to not do that. So we kind of, not that obviously negative, but ideally we have positive systems that everybody actually wants to work together to benefit. And so even if there is an AI, it actually just fits into the same system, right? That oh, actually the most beneficial for everyone is contribute here. And again, this blockchains are really simplistic examples. Bitcoin is a simplistic example of a bunch of self-motivated agents participating because it actually benefits them. to do that and following protocol.
Yeah, it's actually very extraordinary how fast and how well, researchers and academics from US, Canada, UK came together, and how these organizations are spanning out to discuss and address the problems. It's comforting to see this body of really, really experts that have been in the field for decades coming together and discussing this in a open forum. It's beyond the academic conferences. It's becoming more and more public. Governments are taking action by, maybe in different ways. Like UK has ARIA, who's more focused, more maybe government controlled and funded, where US is more decentralized and kind of it allows a combination of government and private entities to take smaller parts. And so,
I don't know. US doesn't make much. I mean, US, at least current set, doesn't make much sense, right? There's like limit on compute. There's like, hey, it needs to check that it's not doing bad things. Like,
right,
very
but that's just
defined, very, yeah.
Right, but that's just a government position, right? There are other players that are having a voice, and I think the cumulative voices around the government are also playing a very important part, and that resonates with what scientists in other countries are saying. So again, I would see that as a huge positive to kind of balance the doomdays approach that circulates in the media. So there was a tweet just hours before we started this conversation from Jan LeCun, the chief scientist, AI scientist at Meta, that talks about the LLMs and they cannot solve problems that they haven't been trained on. They cannot acquire new skills without human help. So don't go there yet. Don't create this apocalyptic view without knowing what's involved. So
Yeah, but I feel like his position is also somewhat limited because he's like, yes, LLM cannot do it, but a system that uses LLM can, right? There's actually a paper today as well, which is a AI researcher or AI scientist paper from Sakana folks, and it's coming up with new concepts, tests hypothesis, runs them, writes a paper, kind of process. So yes, a single LLM may not be able to do it, but Monte Carlo search around it, a set of systems around it can. So
and that's the beauty of having all these voices kind of in the open forum, and being fairly transparent to date, and kind of address it together. So to me, that's a plus.
Oh, for sure. I think the fact that we're having this conversation and able to do that versus it sits somewhere in Manhattan, on a Manhattan project in Los Altos, right on a hill, and nobody knows about this, I think is hugely beneficial.
I really liked the conversations here about how do we think about the system around the AI or the human, and how do we put safety into that system. One of the things that Atlas has really gotten to chat with other people in the wider community about is when we look at safety and security in our most critical systems today, almost always the software is the worst, most vulnerable place. If there's AI, okay, that's even worse. That's even worse in terms of our confidence and our assurance levels. And then, of course, the worst software vulnerabilities are in the old stuff. And we have this tremendous glut of legacy software that does important things, maybe decades old, is not easy to replace, both because it's massive and sprawling and complex, and because incredible amounts of effort went into establishing confidence in the behavioral correctness, at least in domains it was originally developed in. We don't want to throw out all that good work. But now the context has shifted a little bit, or now, we have 30 years of accumulated expertise on how to break in to insecure software. And so there's then this question, okay, how do we shift these infrastructural systems that underlie many of the surface level tasks that humans or AIs are working on? Because that's often the place that our systems are getting hammered badly today.
Yeah, I mean, I think the interesting part is that people actually see those systems that have been there for 40 years and trust them more because they've been around for 40 years. And I think there's an interesting kind of effect here that, like, on one side, especially if it's I think in open source it's definitely better, because like if it's been open source for some period of time. But the closed source, like the fact that it's been sitting there and not being hacked doesn't actually mean anything, because you haven't really exposed it. Like it may have not been exposed, you don't actually know, because you don't have a good way to measure like how much like approaches to finding vulnerabilities actually had. But I do think, I actually fundamentally think we'll need to rewrite the whole internet. And now that we have AI, we can actually probably do that pretty quickly. And we will need to rebuild every single piece of stack, like starting from literally TCP/IP, networking stack, and up to level from there. And while we're there, we add cryptographic, cryptoeconomic security, and all of those things as well, to make sure that we actually have like end-to-end encryption. We don't actually need to have telcos, because we can just pay our way through the networking protocols, etc. But all of that will take time to mature the tooling that is able to do that, and then it will take some immense amount of like product and kind of mental shift to really adopt that, instead of having it as a Frankenstein where now we're like attached another thing on top. And that I'm excited again, because I see the kind of blockchain world is where we found ways to really have living protocols, right? Like the example I love to use is like IPv4, right, to IPv6 transition. IPv6 is a 15-year-old protocol, right? We still haven't transitioned to it. I'm pretty sure I'm still using right now on my laptop IPv4. And this is because there's no like way to come to a global consensus that like, hey, now we're all using IPv4, get out of it, right? Like, you have 6 months, but also like all of the code, every system is ready to do that, and it's just as a transition. But in the blockchain, because we have a global consensus, we're actually able to do that. We can coordinate upgrades like this. And so I'm pretty excited on like this combination of where blockchain will lead the way of kind of rewriting the stack, and then leveraging that to build more safe systems, because the stack is built on kind of this safe concept. Again.
So I'll jump in and say I don't believe in global consensus. I don't believe it's actually ever possible. I think it's, I'm educated from my background working with and around military systems. There's always this question of how do you interoperate or get everybody on the same page. If your answer is, we'll locally coordinate every pair of people, well, dear God, you just signed up for a very expensive task. But if your answer is everybody will agree on how to interact, then how do you know what everybody needs and wants? Is it the same? Do you have everybody in that conversation? Even if somehow you had everybody in that conversation, which you didn't, you don't have the future in that conversation. But I do think there's something compelling in the ability to evolve the protocols that you are naming. And the more that we think about forward and back compatibility as part of the design, and think about interoperability with the things we don't know, inside of the design is a helpful place to go. And then finally, I think, again, shifting more towards orienting in terms of requirements and being a bit hierarchical in what really matters. Can we get clear on what matters? Well, now we have enough, some problems. We've decomposed this. We'll recurse that structure. But the more we stay oriented towards those design considerations, those are the parts that we have higher levels of consensus on. Those are the parts that we can reuse much better. And if we're hopeful, big warning of being optimistic and hopeful here, but if we're hopeful, we can start to imagine the paths by which modern generative AI can help us keep reconcretizing from those high-level designs at a pace that matches the upgrade pace we actually need to rely on at the implementation level, at the solutions that are getting deployed.
All right, my closing thoughts, if I'm allowed, are put people first, solve a problem for people, and take as much as you can chew, and make that solution transparent and put it out in the world, and we'll see how it all fits together and how we all benefit from it. And thanks, Illia, for inviting us here.
For sure. Thanks for coming. Let's keep making progress in all the directions. There's a ton to do, but I'm excited, and I think changing the conversation more toward this kind of like, how do we make systems behave in expected ways, right? I think away from fear mongering around AI, running out of the box and killing everyone, I think is really important, and excited to have this conversation with you guys.
Thank you so much.
Cool. Really great to chat here.
Yeah.
All right. I didn't know if I were supposed to stay or